Hi, this video is to go over question number 6 on Standards Test 3 on radical and rational expressions, equations, and functions. So this video will cover how to do all of the rational expressions and equations. So second page of your review or back of your review. Okay? So we're going to start off doing 6A. So there's not really enough room to do these on the review adequately, so I'm going to do them on a separate sheet of paper. I recommend that you do your work on a separate sheet as well. Alright, so 6A is a multiplying rational expressions equation or problem. To multiply fractions, all you need to remember is that if you were multiplying the fractions 2/3 times 4/5, you would multiply straight across and then simplify if you could. So that's the concept we're going to use here. We're going to multiply our numerators together and our denominators together. 6 times 5, and I'm going to do exactly what I would do if I were you on the calculator. Alright, so 6 times 50, rather not 5. 6 times 50 is 300. And then you're going to list all of your variables. And if you had a repeating variable, you would want to remember to add your exponents. But we have one x, we have one y, and I'm going to go ahead, if I have anything with the exponent higher than 1, I'm going to write out the variable that many times. So if I have z cubed, I'm write out z times z times z. On the bottom, 35 times 18 is 630. I have two x's. I have y cubed, and I have y squared. That's 5 y's, so I'm going to write out y 5 times. And I have one z. Now I'm going to simplify, and I'll be through. So we need to reduce our fraction. So I'm going to type in 300 divided by 630. Math, enter, enter. And I get 10 over 21. So I've reduced this. Now what you want to do is cancel variables if you have one on the top and one on the bottom, because that means that, like for instance, x over x, anything divided by itself equals 1. So x divided by x equals 1, so we can cancel those out. We can also eliminate one y, and there's no more y's on top, but we have one z on the bottom, so I'm going to eliminate one z on the top. And then in our answer, we simply write whatever's remaining, but we write it with an exponent. So if we have z times z, that's z squared, and it belongs on top. On the bottom, I have 1, 2, 3, 4 y's. That belongs on the bottom, and I'm done. That would be my final answer. 10z squared over 21 y to the 4th. Oh, I apologize. I forgot this x right here. Let's squeeze that x in there. 21x y to the 4th. So just be careful. Make sure you go back and look as I did, because it's easy to leave one out, so you want to make sure that nothing gets left out. It even helps to use a different color pen or maybe a highlighter so that you don't leave anything out. And you can use that on your test if you like. For 6B, it's a division problem. What you need to remember about dividing fractions is that when you're dividing fractions, you actually turn it into multiplication. So if I had 2/3 divided by 4/5, I would actually keep the first fraction, change division to multiplication, and invert my second fraction here and get 5/4. Now, because it's just multiplication, I would multiply straight across and then reduce. Okay, so we're going to do basically the same exact thing, just with polynomials. So first thing I'm going to do is rewrite my first fraction, change division to multiplication, and flip my second fraction. Now we're going to multiply this, but what we can do, if you want, is we could go ahead and write it as a product and then factor, but my preference is to factor beforehand, which means I'm going to factor each ratio. So this is a trinomial. It should factor into x minus 4 and x plus 2, because negative 4 times 2 is negative 8, but negative 4 plus 2 gives us negative 2. Here for 3x minus 12, I have a GCF of 3. So I'm basically going to undo distributive property, pull out the 3. 3 times what gives us 3x? That would be x. 3 times what gives us negative 12? I need a minus 4. So just always go back and check and make sure. So 3 times x is 3x. 3 times negative 4 is negative 12. On top here, I notice that they're both divisible by 9, and they both have an x. So I'm going to take out a 9x. 9x times what gives us 9x squared? We would need x. 9x times what gives us 18x? We would need 2. The x squared minus 4 is a difference of squares, so I'm going to factor that out into 2 binomial factors. You should recognize that pattern by now. X plus 2 and x minus 2. So now I'm basically going to finish up after I reduce. So notice that we have certain terms that are divisible by itself. So we have x minus 4 divisible by x minus 4, so we can cancel those. We need to remember that we can cancel vertically or we can cancel horizontally. Notice over here I've got an x plus 2 divided by an x plus 2, so those would cancel. And I also have an x minus 2 divided by x minus 2, so those would cancel. But what we have left is 9x over 3. But even that can be reduced. 3 goes into 9 3 times, so our final answer is 3x. Next, for C, we have an addition problem. Now remember, to add fractions, what we need is a common denominator. So if we're trying to establish our least common denominator, we need to remember that our least common denominator is a term that that both a and b will divide into. It has to be large enough that a squared goes in and large enough that b cubed goes in. Whenever we have the same factors repeated, so notice we have a in both of our denominators, we must choose the one that has the larger exponent. So we would choose a squared. If we've got b cubed and b, we choose the one with the larger exponent. So a squared b cubed is our common denominator. So what I'm now going to do is create 2 fractions where my denominators are a squared b cubed. So this works just like, by the way, if we were adding 2/3 plus 4/5, we would need a common denominator of 15 because 3 goes into 15 and 5 goes into 15. We would then divide 3 into 15 and get 5. And then, meaning we'd have to multiply 2 times 5 and 3 times 5 to make it have a denominator of 15. So 2 times 5 is 10. We'd have to multiply 5 by 3 to get 15. What we do to the bottom, we also do to the top. So 4 times 3 is 12. Then once we have like denominators, we can just add them and then reduce if possible. So both of these are divisible by 3. So that would be 4/5. Okay? So, I apologize, I don't know why I have 12. That was totally 22/15, which would not be reduced. Mistake there, sorry. Alright, so now if we take a look and compare our denominators, we have a squared b cubed, and there's nothing that we need to multiply this a squared b cubed by to get a squared b cubed. It happens to be our common denominator. So therefore, we do not have to multiply the numerator by anything. So we leave it to a plus b. So keep in mind, we could equate that to if we had a fraction with a denominator of 5 and make it 15 rather, and a denominator of 5, our common denominator would be 15. So we would not have to multiply the 15 by anything, so therefore we wouldn't multiply the top by anything. Same concept. We just have polynomials here, or monomials. So we don't have to change this fraction, but this one here, if you think about it, to have a denominator of a squared b cubed, we have one a, but we need 2 a's. So we would need to multiply by another a. We have 2 b's, but we need 3. We would need to multiply by 1 more. Whatever we multiply the bottom by, we also multiply the top by. But if this is a quantity being added or subtracted, we must put parentheses and distribute. So now, for this numerator, I'm going to distribute ab to a. That gives me a squared b. minus, and then 2 times b, 2b times ab will give us negative 2ab squared. So that's our new numerator. Now we have like denominators, so that means we can add our numerators together. So we would have 2a plus b plus a squared b minus 2ab squared, all over our common denominator of a squared b cubed. Now, if all terms had a common factor on top, then we would try to reduce it. So we'd want to see, do all of our terms have an a? Well, they all do except that one, so we can't cancel any a's. Do all of them have b? Well, these last three do, but not this one. So we cannot reduce this. We are through. So notice, it really wasn't much work. We had to determine what was our common denominator, multiply the bottom and the top by whatever we needed to make that denominator a squared b cubed, distribute, and then combine our numerators into one fraction. Okay? That's it. For D, we have a subtraction problem. But we do not have like denominators. Remember, to add or subtract, we have to have like denominators. Well, they look very similar. We have x minus 3 and we have 3 minus x. Recall from class, we taught you that if you wanted to make one appear like the other, then we could essentially factor out a negative 1. So if I divide both of these terms by negative 1, that leaves me with negative 3 plus x. Well, that lets me rewrite it as x minus 3. So now I do have an x minus 3. The only thing I didn't have before was the negative 1. So if you think about it, what we really have here is 5x over x minus 3 minus, and think about this, a 3 divided by a negative 1 is negative 3. So the negative really goes essentially with the top. And because we have minus and negative, we can change that to addition. So at this point, what we should recognize is that really all we need to do is put parentheses around this and change our sign. By doing that, you'll be able to switch it around to x minus 3. So now we have here what we have here. We have like denominators now, so we can add our numerators. 5x plus 3x is 8x over x minus 3. And there's nothing we can do to reduce that, so we are done. Alright, so now for the last two problems on solving for rational equations here, and then that'll wrap up this video. We're going to next cover 7a. I'm sorry, not 6, but 7a. So remember, we taught you in class to eliminate fractions from equations to be able to solve them by using the least common denominator. The least common denominator is the least common multiple of the denominators. So if you think about it, if I try to make all of them have the same denominator, I would need to create fractions that had x and x minus 2. So that's our least common denominator. But the easiest way to eliminate our fractions altogether is to use that least common denominator and multiply every term in this equation by that LCD. So remember, the trick was we take our denominator, divide it into our LCD. The x minus 2 they would cancel, leaving the x. So whatever is remaining, I multiply the numerator by. So now that's gone. X minus 2 goes into x and x minus 2, canceling the x minus 2 but leaving x. So I'm also going to multiply the 2 by x. And lastly, x divides into x and x minus 2 with the x canceling and leaving x minus 2. So I have to multiply the numerator 5 by x minus 2. So I've now created an equation with no fractions. My job is to simply solve the equation left by our numerators. So I'm going to simplify that. X times x is x squared. 2 times x is 2x. And here we're going to have to distribute a positive 5. So that's going to be plus 5x. Positive 5 times negative 2 is negative 10. What we need to keep in mind, however, is that x is not allowed to equal the values of 2 and 0. Remember, we have to state the excluded values for x so that if we get them as a solution, we can throw them out. Why? Because if we let x equal 2 and we substitute it in our denominator, 2 minus 2 would equal 0. And then we would get x divided by 0, which is not possible. You cannot divide anything by 0. So we have to eliminate any potential solutions that would make our denominator equal 0, because division by 0 is not possible. So let's go ahead and define that x cannot equal 2 and 0. That way, if we end up getting it as a solution, we can throw it out as a potential solution. Well, what we have left here is a quadratic equation. I know it's quadratic because our highest degree is 2. I'm going to go ahead and simplify our linear terms here on the right. But now I want all my terms on one side. So remember, to solve a quadratic equation, we need to set it equal to 0 and try to factor it if possible. So I need to subtract 7x and add 10 to make it equal 0. So over here I'm going to have subtract 7x plus 10 equals 0. Well, you shouldn't understand how to factor this. I'm going to show you by factoring, but also by graphing. This does factor into the factors x minus 2 and x minus 5. How do I get that? Because I can multiply negative 2 times negative 5 to get positive 10, but add negative 2 and negative 5 to get negative 7. So these are our factors, and remember, to solve by factoring, we set each factor equal to 0, but you should be able to do that in your head. If I set x minus 5 equal to 0, then x equals positive 5. So I have two solutions, 2 and 5. But let's look back here. What did we know? We know that having a value of 2 makes our denominator equal 0. So that means here I want to exclude 2 as a possibility. So we would like for you to show that you understood how to get the two values, but that one, in this case, was excluded. Now, if you have trouble with factoring, please remember that as long as you can set the equation equal to 0, you can use your calculator probably to find those intercepts. So if we have x squared minus 7x plus 10, and we graph it, we can see that it crosses at 2 and 5. If we look at our table, we see the order pair 2, 0 and 5, 0. So we can use our calculator once we get to this point if you have trouble with factoring. But remember to state your excluded values. And lastly, for 7b, this time we're solving a quadratic equation that has like denominators. So once you have like denominators, guys, you should recognize that if two fractions are equivalent and their bottoms are the same, then that means their tops have to be the same or they would not be equal. So that means to solve this, I essentially can ignore x minus 7. If I thought about it like I did up here, if I was to multiply both the fractions by x minus 7, they would both cancel. So really all I'm dealing with is x squared plus 41 equals negative 3x plus 111. So similar to what we did up here, we should recognize that it's quadratic, but beforehand we should go ahead and establish what x cannot equal. So if we were to set x minus 7 equal to 0, so x minus 7 cannot equal 0. We add 7 to both sides. X cannot equal 7. Okay, so we need to make sure when we solve, we don't get an answer of 7. Any other answer we get should be valid. So remember, to solve the quadratic equation, we're going to do just like we did up here. We're going to set it equal to 0. Hopefully it's factorable, or we can use our calculator to find those zeros. So I always leave the quadratic term on whatever side it's already on, as long as it's positive. So that means I'm going to move these terms here on the right to the left side. So I have to add 3x and I have to subtract 111. Well, so that gives me x squared. I can't add the 3x, so plus 3x. But 41 minus 111, 41 minus 111 is negative 70 equals 0. Well, it should pop in your mind that this is definitely factorable if you think about factors of 70 that you can use to get 3. Well, 70 is 7 times 10. So can you use 7 and 10 to get 3? Sure. You would need a positive 10 and a negative 7, because 10 minus 7 gives us 3. So that means when we find both of our zeros, they are negative 10 and positive 7. Oh, wait a minute. What did we notice from up here? X can't equal 7 because it would make our denominator 0. So we have to exclude 7 as a valid solution. So that's what we would expect to see. Good luck on your test.